Hello. Can you hear me? Thank you. There's a lot of you here, by the way. I just want to let you know. So just want to start off by saying welcome to the first React London Meetup of 2019. So good that so many people could make it today. I'm sure you're acquainted with the food and drink outside. If you are 2 or 3 beers deep by now, the toilets are just straight out just there. So my name's Rain, I'm a software engineer at Red Badger. Red Badger, for those of people that don't know, Red Badger is a digital consultancy, and we help our clients create awesome user-centered products, and we also run this meetup as well. So just want to have a little shout out to the folks from Code Bar. Thank you. GA. Founders and coders. And obviously a big thank you to the team at Facebook for letting us host the event here. So we have 3 great talks on today. First up we have Elias from Theodo, who's going to talk to us about testing component behaviors with Jest and Enzyme. We then have Matt from Finimize, who is going to talk to us about high-speed product interaction with Relay. And then last but not least, we have Ono Frios from LabStep, who's going to talk to us about state management with Redux. So each talk will be about 20 minutes, and we'll have a little Q&A session afterwards. We're going to do the first talks back-to-back, and then that will be followed by a little break, and then we'll do the final talk after that. And then after the event, we've got some space booked at a pub just outside the building called the Marquis of Granby. So if you fancy a few more drinks, please join us there. So without further ado, I think it's time we introduce the first speaker. So if you could put your hands together for Elias, please. Thank you.
Cool, thank you. So good evening, everyone. So my name is Elias, as you heard. I'm a web developer at Theodo. So on a daily basis, I develop websites and mobile apps for clients. I use React and React Native in the front end. And today I decided to talk to you about front-end testing. Like when I talk to developers, whether they are my friends or colleagues, I notice like a lot of front-end projects don't really spend a lot of time testing the front end. Some people rely on typing, or some people like stick with just snapshots only. They don't want to spend a lot of time about that, and I think that's too bad because that makes developers having less trust in their code. And I think the main reason for that is talking to people that people don't really know how properly to test a lot of stuff in the front end. So today my goal is to show you a few tricks with Jest and Enzyme to test different kind of features on your front-end code. So I'm going to talk about Jest and Enzyme, which are the technologies I use on my projects. Jest is a test runner and an assertion library, and Enzyme is a really cool library developed by Airbnb that provides you a lot of different functions that enables you to play around with your components and access their props and manipulate them to test a bunch of features. So I'm going to first show you how to test your DOM. It's going to take a bit of time on this part. It's not really reflect the time I spend, like proportionally speaking, on testing my DOM, but it's more a good way for me to introduce you to the main functions that Enzyme provides to test like your front end, which are shallow, mount, or find mainly. And then I'm going to quickly speak about how to test your style, and in the third part, I would insist more like behavioral stuff, dynamic stuff. So user interaction or state update, component rendering, stuff like those. So first, how to test your DOM. So here I'm going to take a simple example. So I'm cheating a bit, it's React Native and not a React example, but I have a simple page here with a title, a text, yes, no, form, radio button, and a next button and a back button at the top. So this component is simply structured as this. So you have a fixed header page, which is like a generic page component that we use to generate the page. So it includes the title and the footer and the back button. And then you simply have a question text, a text component to display the text, and a Redux form field to wrap the radio button component. So what I want to do with this component is to, for example, let's say I want to test that I use the generic. Sorry, I'm going to come back. I use the generic header page component to generate my page, or that I use the Redux form field. So I want to check that. So how is it going to work with Enzyme? So I'm going to use a method called shallow, which enables you to render your component and then provides you a bunch of interesting methods to access your component's children and their own props, and then you can check a bunch of cool stuff. So here, how it works, so I import the shallow and I import my component. I define the props I want to pass to my component so that it actually renders correctly. And then I pass my component to the function shallow. What do I want to do then? I'm going to find the component I'm interested in testing by using a method called simplyFind. So different ways to do that. So my goal is like to find the component I want and check it's there. So I'm going to find, so first I can like use the display name of the component, so simply a string that you pass to find. Another way is to import the component itself and to pass it to the method. A third way is to use a property selector. So you're going to say, I want to access the component, which prop, such prop has this specific value. Or you can use CSS selectors as well, IDs or class. So first test I wanted to do was to check that my header page component is actually there, and I have like one. So I can use the length property, like the find method, like outputs an object thanks to which you can access different kind of methods or values. Here's the length one, and thanks to that you can check that the length is actually 1, not 0 or not 2. I have actually one header page component. So that's the first test. Then what can I check as well on that specific component? I can check that I actually use the back button and it's present. So the back button is generated by my first generic header page. So I'm going to find the header page still and access a method called props that finds outputs and access the pill button text of this props object and then check that it actually equals back. So I have a back button and not a next button or anything. So I have the right prop, and I can check that the field, the Redux form field, also have the value prop equals to yes. So thanks to this props method, which outputs like an object with all the props the component you found has, you can check this kind of stuff. What if now I want to check, for example, something a bit more interesting, that the next button that is at the bottom of this component is disabled when I arrive on the page. We usually have like disable logic when it's about buttons, so it's quite interesting to test that. Here we saw on the structure of this component that the next button is inside the generic page button we use, and shallow only enables us to access the first level of DOM rendering. So I need to mount my components. And so I'm going to show you what's different between shallow and mount. So as I said, shallow only renders the first level of DOM. So we see the header page, the text, the Redux form field. And thanks to mount, I will be able to access like deeper components. So to give you an example, it renders like this. So I can see like the header page, but also every single layer inside and every single children in the whole DOM. And I can actually see my pill button here, if you have a look. So I'm still going to use the same. Oh yeah, sorry, no. So if it works like shallow a bit, but if you are Redux users and if you use Redux a lot on your front-end application, you might have a problem using mount like this because there is a high probability that like one of the children in the whole DOM of your component is connected to the Redux store. So you're going to end up having this kind of error in your console. Like the typical one is violation could not find store in either of the context of the props of this or this component. So what you're going to have to do is to wrap your component with a provider, a Redux store provider that you're going to import from Redux, and pass it to mock store. How do you mock your store? The simplest way to do it is by defining a mock store object, which has 3 functions: a getState function, which returns the state you want to pass to the component you test, then a subscribe function and a dispatch function that you're going to mock. So the dispatch function is the one that's going to help you trigger your actions. And then we can mount our component, and then from there I can actually use mount and access like the low-level components I want to test. So I'm still going to use find because mount and shallow both output the same object, and you can use it for both the same methods. So I'm going to use find. I'm going to try to find something called button, so still using the display name selector. and check that the disabled prop of this button is equals to true when I arrive on the page. But the problem I will have with this one is like I can only apply the props method to after the find method if find actually finds only one component. In our case, we have 4 buttons on our page. So you can use another find selector, as I explained you earlier, the prop one. So I can try to find the button prop, which has the button next prop called next, because I want to find my next button, and that would work. And then I can check that the disabled props of this button is true. So that works. An alternative with Enzyme is also to use the get methods, the last method or the first method. So the get method enables you to find like the indexed component that you found. It's 0 indexed, so in our case we want to get the 3rd one. So the next button is at the bottom of the page. Or you can try to get the last one, that works as well, with the last method. So the first doesn't interest you in our case, but it works exactly the same way. But like it's a bit painful to test all of your DOM like this, trying to access all of the children of the component you're trying to test, all of the props, and check the right. So a really common way to test your DOM is to use snapshots. What is a snapshot? Basically, it's simply like a picture of your DOM, and it renders every single component it has, and like that's a picture you have. So how does it work? It's provided by Jest, and you can shadow your component still. And simply you're going to expect the component you shadowed to match snapshots. So if it's the first test you write, the snapshot, so the Jest is going to create a file outputting like a picture of your DOM. And if your test already existed, when it runs, it's going to take a new picture and compare the new one with the former one. If they are different, the test fails. If they're the same, the test passes. So you can see here that how it renders. The picture of like what is in the output file. It's a bit ugly to read like this. We don't really understand what's in the snapshot. So there is a really cool library to use if you want to have like clean snapshots, which is called Enzyme to JSON. You pass it the component you shadowed, and so it provides a to JSON function to which you pass the component you just shadowed, and then you have a clean snapshot. You can see on the right here that we see like the header page. The text component, the Redux form field, is quite clear to read. You can also use mount to snapshot stuff, like same as usual. So we mount using the provider, and we use to.json, which works as well, and we check like our component match the snapshot. It's way longer because mounts like go to a deeper level. So what to choose between shadow and mount for snapshotting your components? I'm not sure. Mount is more like integration level because like you can take a picture of your whole DOM, and shadow is like a bit like unit test level. So that's the difference between the two. A main downside of the snapshot is that they're very easy to update. So if you see that the snapshot test is failing, you can update it with only one command. And if, for example, you use mount a lot on your front-end application, if you have a single component that's present everywhere with a bit of logic in it, and you modify the logic of this component, it's going to make all the snapshots break. And you're going to have like 50 or 60 snapshots failing on your computer, and there is a high risk that a developer doesn't see a mistake or just lazily updates everything, and you have a regression in your app. So that's the main downside of the snapshots. So what I recommend, obviously you're not going to test everything manually, but for example, I would do a mix of snapshotting and proper feature testing. Typically the disable stuff I was mentioning before, like to check that your button is disabled following the logic you want, I think I would like use find and find the prop and check it's disabled manually, and for stuff like text displaying or button displaying, I would use snapshots. Quickly, I'm going to show you how to test your style. So I'm going to show you how to test style, but only for people who use style components. I use style components on my projects. I have no solution to test like your style if you don't use style components, unfortunately. We're going to use a new method provided by Enzyme, which is called render. It's used the same way as shallow and mount. Same as mount, it renders like the whole DOM of your component. So we need to use the Redux provider. But it's like way uglier because unlike mount, It's not going to render like the React components of the DOM, but like the HTML ones. So it's really hard to read. So I don't recommend you to use render if you want to test your DOM. But the really cool thing if you use style component is that thanks to a library called JStyleComponent, by importing it, you have the class in your the style in your snapshot. So JStyleComponent is going to generate classes and associate them with parts of the HTML DOM. So this way you can snapshot the style, and if you have a style regression, you can spot it in your test. But again, the snapshots are hard to read, so maybe you want to do something more manual and something more concrete. And you have a toHave rule method provided by the same library, JStyleComponent. If you have a style component, you can render it and check that this color property has this style property, this CSS property has this value. Could be useful to test your style because, especially with style component, you have JavaScript in it, so you have like, I know that on several of my projects I put logic in it, in the style itself. So at this point, we saw like 3 main Enzyme methods: shallow, mount, and render. So the main difference is that shallow renders only one level of DOM, and mount and render render like the whole, like an infinite level of DOM and the whole layers of DOM of the component you want to test. So shallow is more unit test material, whereas mount and render are more integration test material. The difference is that shallow and mount give like outputs a wrapper object that provides you with a lot of methods to manipulate your component, whereas render renders to a string. So to manipulate our DOM and to test more functional stuff, we're going to use shallow and mount, obviously. And render, we're going to stick it to style testing. So now I'm going to dig into more behavioral stuff, like, as I said earlier, user interface, state rendering, state updates, stuff like those. So first you want to test user interaction. Button clicking, form unchange, on key press, stuff like those. So I'm still going to keep the same example. And I'm going to mount my component because, as we saw, mount enables you to access like every single children in of the DOM layer. How do I simulate a click or on key press or an unchange? There is this method provided by Enzyme called simulate. And what I have to do is find my button and like apply simulate click on it. So I pass click as a string, and it simulates a click on my button. It might be sometimes, like especially on React Native here, that it doesn't work. So you can like find the props and trigger the on-click prop, and that would work as well. So that's fine. And after I simulate the click, so the edge, sorry, I haven't precised. Like the edge case I want to test is like I want to click my button. What do I want to test? I want to test, for example, that it redirects to the right page if I click it. Good test case for that, good use case is that, for example, on my app, I have logged in customers and non-logged in customers. So for logged in customers, I want them to be redirected to like the following page. And for non-logged in customers, I want to redirect them to the registration page because I want them to register. So I'm passing like the right props, etc., etc. I press the button, and then I can check that the right action has been dispatched, and for that I used to have been called, provided by Jest. So I have already mounted my component and provided it with a mock store. So I can check, I can expect in my test that mock store.dispatch, dispatch function I passed to my store, has been called with the right navigation action with the right route name. And I have my routing tested in my app like this. You also sometimes like want to test that you have like one of the component's behavior depending on the values of some properties in your state inside your class component. So you might want to access your state to test that it updates correctly. So we have a use case here that I'm going to introduce to you. Let's take a simple example of a page where you have a model and a button. So you have a button on the page. When you arrive on the page, you have only the button. When you click the button, the model opens. And when there is a button in the model that closes the model. So I define a simple class component here with the state inside which you have a show model variable that says true or false according to the model is shown or not. You have a random model method that returns the actual model component. You have a close model method to close the model and to set the state variable to false, and an open model to set the state variable to true. And then in the render part, we only trigger random model if the show model variable is true. and we have the button underneath. So what do I want to do? I would like to test that when I click on the button, the model opens. So I'm going to test that when I click on the button, I have the state variable that is true. For that, I need to access the state of my component. So I'm going to use a method called instance, provided by Enzyme as well. So an instance enables you to create an instance of your class and then to access all of these methods or properties defined inside. So here so first when I arrive on the page, I'm expecting that my model is not here. So I'm going to check that model.length, wrapper.findModel.length equals 0. And then I'm finding my button. I'm going to simulate a click. And then I can expect my wrapper.instance.state. So here is how I access the state. The show model is true. To go further, we can test that the model length is now 1. It's what we want to test in the end. But the problem is, what do I want to do? So I want to check first that when I find my model, the length is 0. Then I click, and then the length is 1. That's what we want to do. But it won't be enough, because actually when you simulate a click, it won't re-render your component. So it's going to update the state, but the component is not re-rendered. So you're going to have to use a method called update that forces the re-rendering of a component you shallowed. So here it goes. I shallow my component. I expect first the model to be 0. Then I simulate a click. Then I update my component, re-renders it. And then it uses the new value of the state that has been updated. And now I have my model to have a length of 1. Another cool trick with classes component is the use of spy on. So to illustrate that, I'm going to say that to test still that my model is triggered, I want to check that the random model method has been called when I click the button. So what I naturally go without is I instantiate my component, I simulate the click, I trigger the update, and then I expect the component instantiated dot random model to have been called. But the problem is to have been called, the jest function I introduced to you earlier, it needs to have passed a mocked function, and our component that random model is the actual method that the class provides. So we need to use spy on. The only way to do that is to use so that spy on is like a mock function used by jest. I'm not going to go into detail into that function because I don't want to talk too much about mocks, but how does it work? I spy on the random model of my component, then I can simulate the click, then I update my wrapper, and then the function has been called. Last example I want to give you is something that enabled me to avoid the regression on the project, actually. I'm going to take a simple example, which displays a prop, a prop which gives a name. And actually, I want to test that somehow the prop name changes. First, it's undefined because I loaded it from backend. First, it's undefined, so it's loading, and then it's actually displayed. And you could test first that by passing the props undefined, your component renders well, and in second time, by passing the actual prop, it renders correctly. But it doesn't reproduce the loading part and the re-rendering part, which can cause, which is interesting to reproduce. So by using set props, so you first so you define a new name, you shallow your component again, you check that the first snapshot is right, then you set your props, the new value, the component re-renders, and then you have a new snapshot that you can test. And you actually simulate the re-rendering of the component. So, yeah, in conclusion, a bit of the downsides of unit testing is I think you can't test everything in your front end, and it will never be as efficient as perfect end-to-end testing because it stays unit testing. That's the Hudon style of it. But I think with all of that introduced to you, I think you can test quite a bunch of stuff, interesting ones. Alternatives to unit testing, people who talk to me about I don't want to test my front end and gave me reason. Some people say typing is enough. If you cover your whole code by flow typing it, for example, that would be enough. I think it's a good practice to type your code, but I don't think it's enough to cover your test with cover your code with the tests. So I would say that unit testing and typing are complementary. More than one is more useful than the other. Some people rely only on the snapshots, but as I said earlier, the snapshots are very risky to rely on because you can easily update tests that break without realizing there is a mistake. End-to-end tests seem to be the perfect answer to everything, but in my experience, they are very hard to set up and usually a pain. So, yes. Thank you.
Thank you very much, Elias. So we've got a little bit of time for a Q&A, if anyone has any questions. You just have to raise your hand, and one of the guys from behind will just come and give you a little microphone. So do we have any questions? Just here. Thank you.
Yeah, so when you create, say, some components for a page, do you create your component and your view first and then go and build your unit test, or do you build your component and unit test at the same time?
I write the component first, and then unit test it. Maybe not the right practice, but like feature first, I guess.
Do we have any other questions?
Can you think of a use case for Mount where you don't conflate different responsibilities of components?
What do you mean, different responsibilities?
So you were talking about with dive. If you want to access something that belongs to another component, you have to dive into it.
Yep.
So I would expect that component to handle its own test. And then with Mount or dive, you're kind of going into something else that should be handling itself?
Yeah. Yeah, I have used. Yeah, I was thinking of it by preparing this talk. I had a use case on a project recently, whereas we had like this progress bar, so which had this like its logic itself, which was unit tested, and I modified the logic of this progress bar, and then it broke like 60 mount snapshots, which was like because it was used on every single page and on some subcomponents of those pages. So like yeah. Like the logic was already unit tested somewhere and didn't need to be tested on the mount snapshots, but it was because like it was inside the snapshots. So it made the snapshot broke for no reason because, yeah. Is it like, doesn't that answer your question or?
Sure.
Okay.
Yeah, hi. How do you handle snapshot tests in your build pipeline?
They run on CircleCI when every test runs.
So when they change, it just updates them and.
No, like so the developer is supposed to run the test locally first. So if he did his job correctly, like the test will pass on Circle, and otherwise it will break on CircleCI and not update themselves. Like
Okay.
they don't update automatically. Like we don't say by default like let's update them if they break.
Thanks.
Okay, I think we'll move on to the second talk. Thank you very much, Elias. Very good talk. Thank you. Okay, so next up we have Matt. So can we please welcome Matt up to the stage? Cool.
Cool. Yeah, so hi everyone, I'm Matt, VP Engineering at a company called Finimize. So yeah, maybe before I dive into the talk, it'd be cool to give a bit of context as to who we actually are. So has anyone heard of Finimize? Hands up. A few. Cool, so I think we're basically trying to solve a problem that I imagine lots of people in this room probably have. So I think probably most of us are earning a salary. I imagine we try and save some of that salary every single month. But I imagine that not that many of us actually know what we should be doing with that money. So we're trying to tackle this problem of financial literacy, particularly in young people and millennials. And we want to get you feeling more confident investing your money, putting your money to work, and starting to grow your wealth. And our ultimate vision is to increase the net wealth of our generation. So we actually started life as an email newsletter. So that basically takes the key financial news stories from the day, and we write them in kind of plain English, no jargon, takes 3 minutes, kind of quite a fun, snappy fashion. And that's allowed us to grow a real community around that brand. So we've scaled this now to 300,000 subscribers. And what's really cool is we've kind of built a community, we've got events, and they've actually become self-organizing. So we've had people run their own events in like Lagos in Nigeria and like Chicago and Dublin. So we've built quite a buzzy community out of just an email. And then last year we launched our mobile app. So this is taking a much more holistic view on the problem. And you'll find a number of features there. So we do kind of financial educational material. We do news updates, and we do provider comparisons. And the theme here is really about empowerment. So we want to teach you how to make your own decisions and not just tell you what to do. And yeah, we've been picking up some accolades for that. So we've actually been featured by Apple twice, most recently as App of the Day. And we got into Product Hunt's top 3 fintech apps of 2018. So yeah, that's what we're talking about today. I think building a good consumer mobile experience is super tricky. So you need to do a lot of experimentation to find out like the best way of solving the problem, the best, I suppose, way of getting your users to understand how to use your product and come up with the best experience. And so given that we knew this from the outset, we kind of run into some technical requirements. So from our tech stack, we want the ability to be able to iterate super quickly on what for us is quite a data-heavy app. And what I mean by that is we're kind of presenting a lot of data from the database, a bit like Facebook, I suppose. And that's the bulk of the logic we're writing. We want the ability to add, change, and delete features very easily and iterate quickly. And we want it to be easily maintainable. So hopefully we can write as little code as possible, and we can get our frameworks to do as much heavy lifting for us as they can. And so what do we go with? We chose React and React Native, obviously. We went with GraphQL. We chose Relay. And then in the back end, we went for Django and Python, which we're not going to dive into, but may be interesting as a bit of context. So I'll start by saying what I don't want to talk about. So I don't want to get into this debate between Relay and Apollo. I think there are thousands of blogs on it online. And I think actually a lot of the best practices I'm going to talk about, you can actually do with Apollo as well. I think in terms of our decision, with Relay, it was predominantly about like technical expertise on the team, and also I guess making a bit of a bet with Facebook having some nice integrated tooling with the rest of the Facebook stack. What I do want to do is kind of go through some of the Relay learnings and best practices. I think a lot of the stuff that we've come to think of as the basics and principles like weren't that obvious when we started out. And maybe for those of you starting new projects, we can help you select your tech stack. And I suppose as a bit of added context, our experience is coming from Redux without GraphQL. So yeah, super basic. Sorry if it's trivial. What is Relay? It basically sits in your client, fetches GraphQL data, brings it back, and then passes it to your React components. And Apollo would play a very similar role. So yeah, let's take an example from our app. So here we're comparing between different providers. And what we want to do is kind of show for any given provider like some company information, as well as some community reviews on that product. And this is pretty representative of our problem in that we're kind of visually representing a lot of data from the database. So let's have a look at how we might break that down. So yeah, if we take a basic kind of React structure for this, you have your review screen, got a company header at the top, reviews panel, and then some review thumbnails. And then this on the right here is a potential GraphQL request for that. And hopefully, even though those of you who haven't worked with it, that's hopefully still quite readable. So we basically want, so we have a viewer at root, then off that we want the company, we want the name, we want the reviews, and then we want some fields on each review. And I suppose an important thing to bear in mind is that in GraphQL world, that's like a single request. So we're not in this kind of RESTful space where we're making different API calls to different endpoints. And so if we look at how you might start to represent this in Relay, you bind your top-level component to a query. So I suppose when you're thinking about this, when you hear query, just think of like a single API request. So I guess on any given screen, you want to try and limit how many API requests you're making. So the top level is getting your query. Then the components beneath that use what's called a fragment. So a fragment is just saying, with the data I get back, I want this chunk of data. So it's not making any extra requests or anything like that. It's just requesting from your query. And so with our company header at the top, we've got a fragment on company, and we want the name. And then on our review thumbnails, we'll have a fragment on review. So that's the kind of GraphQL node we're working on. And off that, let's say we want the username and the review text. And so if we structure our components in this way, we get a number of benefits. So now each component is stating exactly what it needs from this top-level query. And we found that to be super declarative, really descriptive, because what you've got now is your data alongside your component. And it also kind of avoids these big chains of props that we found in the Redux world, where you've kind of got to pass down and maintain like different data points being passed down as props. So let's have a look at an example. So this is the top-level query. And let's just say we've got a component here at the top. We're going to co-locate our relay data alongside that. And there's a lot of syntax here, but hopefully it should start to explain itself. So the query renderer is a relay concept. It's basically a component that fetches the data from the database and returns it. With query renderer is just a function that we've built to wrap that. And then within that, what we're doing is defining our query. So you can see we want our viewer, we want the company, and then here what we're doing is defining which fragments we're going to pass down to. And the syntax there is by convention. So it's the component name underscore and then the prop, or the kind of GraphQL node that you're working with. So this is basically saying we want to pass the company down to the company header component. And then similarly underneath, we want to pass the review to the review thumbnail. And so if we dive into what one of those fragments looks like. So again, we co-locate the data here, and we've got the fragment sitting there alongside the component. And so all we do is declare the data we want from that initial query, and then that will appear as props within the component. And so we've found this to be a really nice way of working, because now you've got this kind of nice, self-contained, descriptive component setup. And if you want to like change or delete or modify whatever data you use, you just go and change within this file. And so I think it's quite nice, and it encapsulates concerns a little bit. And so 2 tips. So these are both super simple, but we found it makes managing Relay way easier. So firstly, be like explicit about passing down props. So you shouldn't be needing to pass down quite as many as we would have done in the Redux world initially from our code base. So where you see things like this, we've come to see that as a bit of a red flag. I think always better to be explicit. Then secondly, be super strict on fragments. So one thing we did initially is we would kind of build a relatively trivial component that used some data, not put a fragment alongside it, just be a bit lazy, and then we kind of pass down the data from above. What tends to happen is the scope creeps, 2 bits of data become 3, become 4, and then you've kind of got this big chain of props to manage. So I think no matter how trivial the component, be kind of really strict about giving it a fragment alongside it. So next, mutations. So this is a GraphQL concept again. And that basically means an update if you've not worked with it. So a good example of that is marking an article as read. And yeah, I suppose what we normally see with a server update is some kind of corresponding UI update. So we've got an example of that here. So we've got 2 articles there, and now we're going to read an article. And then once we've read it, we're going to mark it as read. And what we want to happen in the UI is for one of those articles to disappear off the screen. There we go. So that's quite common. Generally, when you make an update on the server, you want the UI to be updated as well. And so Relay behind the scenes has its own internal state. So it's a bit like Redux. It's similar to a Redux state. So you've got all your kind of GraphQL nodes here. And they've got all the fields associated with them. So we've got name in is read potentially on the article. And when we make a server request, some kind of mutation update, when that response comes back, Relay is going to then update its own internal state. So that happens automatically, which is really nice. But you can actually go one better than that. So you can use what's called an optimistic update. So what that says is I'm expecting this response back from the server, and when I get it back, when I get it back, it's going to update automatically. But what Relay will do if you give it an optimistic update is it will kind of do it straight away as soon as you make the request. So let's have an example of that. So yeah, so we've got our mutation here. Again, there's a lot of syntax here, but hopefully it should become obvious. At the top, we're defining our mutation. Within the mutation, you define what you're going to return back from the mutation. And what you write there is generally anything that's going to be updated as a result of that update. So we're expecting our article to be marked as read. And we're expecting the user's reading streak to be updated. So that's just like how many days a user's read in a row. And you can optionally pass in this optimistic response. So this is what we're expecting to come back. And you can see that we're expecting the article to be read. And then let's just say we're expecting the user's reading streak to be 1. And so it's going to immediately update its own internal state once you make this request. And so you have this really nice, like, fluid feel to the UI where stuff's changing as you interact with it. It's not waiting for a response back. And basically, in the event of an error, it will roll the UI back. But in the general case, it will just kind of make things feel very instantaneous. So finally, we're going to talk about typing. So we use Flow for this, which is another Facebook tool. But TypeScript works just as well. I think TypeScript does a similar thing to what I'm going to show you if you're using like Apollo and Node. But we get this Flow integration with Django. So as a tiny bit of context, here's how we define GraphQL models on the Django side. So this is our company node, this is our review node, and we're going to define a number of fields on that. So we've got a username, and we're expecting that to be a string. And where you've got this required equals true argument, what that's saying is that this string cannot be null, so we're guaranteeing to get a string back from that. So we've got the same situation with the review text underneath. With the upvotes and the downvotes, so we're expecting integers back from those, but this is saying they can be null or undefined. And so obviously that has implications on the client, because you want to now check whether those variables are defined. So what Relay does is it gives you this build step. So in a way, this is like a little bit annoying, because you have to add it to your CI pipelines, etc. But what it essentially does is gives you a schema in the server and in the client. And that gives you kind of a mutual understanding of what you're expecting to get back from the server. And as part of that, you get these flow types generated in the client. So again, to see how that looks, let's go back to our example. So at the top there, we've got this __ generated folder. And basically, that's a kind of generated directory from this build step, full of types for our queries and our fragments. And so we can pull out our review thumbnail _review fragment type, which matches this. And then at the top, you can kind of set that to the props in your standard kind of flow way. Now, when we start messing about with stuff in the component, if we're playing around with upvotes and we try and do something that requires like an integer, it's going to flash up a warning. And so we found this like to be a really good way of kind of catching very common bugs. It kind of saves you writing some tests because you can avoid like having to check some of the edge cases. And so if you kind of look at this structure as a whole, so all of our components look like this, super easy to change, pretty robust, and basically we've just found this kind of way of writing React code to scale really well, and scale really well with a lot of kind of changes made to it, which I think is quite important. So to wrap up, I think used in the right way, Relay and Apollo encourage like this really descriptive, declarative, very nicely maintainable code base. I'd encourage the use of optimistic updates for super quick feeling UI. And I think if you're starting a new code base, really good to go straight in with like server-generated typing to catch any bugs and edge cases. And I think that whole thing, you end up with a really nice kind of tight data binding between your server and your client, and everything in the middle is kind of handled. So we found having that taken off our hands to be like a really good thing. So going to end on this inevitable plug. So we're hiring. So if that sounds interesting, we're looking for anyone kind of talented, ambitious, and like product driven. So if this sounds like something you might want to work on, please do come have a chat and or get in touch via the email. So yeah, happy for any questions. Back.
Hello, thank you
Hi.
very much. I have actually two questions. I'll try to keep it short. The first one is actually about testing. Basically, I assume that for your unit test, you can just test the pure components, but do you also have any sort of testing to mock the sort of GraphQL or somehow? Because it seems like this is quite high level in a way.
It could be. I mean, I think you could do that. I think we've actually not really found too many problems doing that. We prefer to be strict about our typing and like add it to our build pipeline and stuff. I think with a kind of combination of the testing frameworks we've shown earlier, as well as some of that typing, we found that gets us most of the way. To be honest, I haven't looked into what kind of frameworks you get with Relay in terms of testing. I think you can. There's a pretty good like mocking library you can get, but I don't think it will give you that like end-to-end testing that I think you're getting at. Was that kind of the question?
I think so. And the second one is basically about when you say you actually use Flow to kind of have consistent like sort of typing across backend and frontend. Can you also generate like native React prop types using the same kind of tools, or they're just kind of restricted to use Flow?
Good question. Possibly, if you can do that, it would be on the node side. I know that with like Django, which is what we use, it tends to just be Relay and Flow that you get support for. It wouldn't surprise me if Apollo supports that, because Apollo is very like fully featured and kind of catches a lot of edge cases like that. But worth double checking.
Thank you very much.
Hello. Yeah.
Hey.
Just a question on the optimistic response.
Yep.
So what happens if the server responds with a completely different response to what you kind of expected, or is it usually just for like trivial stuff like on and off kind of stuff?
So the response from the server will just override whatever you've said, basically. But that would look weird, so you probably wouldn't do that.
Yeah, I was thinking the UI is going to kind of jitter, I guess.
Yeah.
Between the two states.
Yeah. So really, it's only for stuff where you know what the result's going to be.
Yeah.
Which actually is kind of in more cases than you'd think. But it does kind of help create this like very smooth thing when you're using it everywhere. This very kind of smooth feel to the UI. Yeah.
Cool. Can I just squeeze one more question? Yeah. You mentioned as well that Relay has like an internal state.
Mm-hmm.
So does that work in I know you don't like to mention Apollo, but does that work in the similar way to Apollo Store in that you kind of?
I would think
Redux,
it's probably almost exactly the same. Yeah. Yeah. It's you can like manipulate it manually as well. So if for instance you had a complicated optimistic update where you wanted to play around with it and kind of do kind of Reduxy things to it, they do have an API to allow you to do that. But yeah, I would think it works in a similar way.
Cool.
You can go and interact with it and stuff, so it's not completely hidden away.
Cool, thanks.
Mm-hmm.
Thank you. On the back end, do you have a monolith, or you have different services that communicate with your GraphQL API?
Currently, we do, yeah. I mean, Django's pretty good at giving you like a nice broken down structure, so it works with like separate apps. So you can get pretty far with a monolith.
Okay. I assume it's also a monorepo, since you build your type
So
from the back
it isn't actually. We kind of hacked that. So we have a script that kind of generates that into the client directories.
Okay.
The reason I say the build set's a bit annoying is because to run that in a CI pipeline, we had to actually check out the server in one job, run it, and then kind of bring those artifacts into the client directories.
Okay.
So there's like in the client jobs because we use Circle CI, in the client jobs for that, there's actually like a couple more steps. But it seems to work okay, and I haven't really seen a good workaround to that. And I suppose the price of that gets you like all these kind of bonuses. So it's kind of a trade-off, really.
Okay, thank you.
Cool. I think one down the back.
We've got time for one more.
Hi. Does Relay handle any of the sort of suspense stuff while data's being fetched for you, or do you have to handle that, or have you found it's not enough of a problem?
What do you mean? Handle suspense stuff?
So, say you've popped up that company page while that data's being fetched to populate the actual data. Does it provide anything to handle that, or do you have something?
So you can handle loading states yourself. Generally, what tends to happen is you have your query at the top level, and so we by default just return null. So you see, actually, earlier on, I kind of had that function with query renderer. So that was a custom thing that we built to add some extra behaviors in. And we just, by default, return null while it's loading. So if that's the top-level screen, that's kind of fine. And then if you've got a subquery, so within a page, you can add like a loading indicator or something. So we built like a kind of standard way of doing that. But it's pretty simple what we built, and it seems to hold up in most cases. So it doesn't really handle it, but it's pretty easy to handle yourself. Cool.
Brilliant. Thank you very much, Matt. Okay, so we're going to take our break now. So please feel free to head outside, stretch your legs, have another stab at the pizza, and be back here for in about 15 minutes or so, and we'll have our last talk. Thank you. Okay. Hello again. I hope everyone's well fed and hydrated, ready for the last talk. So if I could please introduce Onofrios. Thank you very much.
Spoiler alert. Good evening, everyone. My name is Ono, and tonight I'm going to be talking about state management with Redux. And when I talk about state, I mean all of the information retained by our program at any given time. When we do an API call, for example, to fetch some data, maybe a user or some posts, we need to store that data to later make it available to our main app, our components. And when we store that data, that becomes the state of our application. And state management is the method that we manage the data. It's how we update it when we do some more API calls, for example, we fetch some more users, or we update a user's name. And state management can be quite tough to set up, especially the first time we come into this React world. We kind of have all these questions: where do we store the state, in our components, maybe somewhere else? And fortunately, we have a great community that provides us with lots of open source libraries. And one of them is Redux. Redux, as the authors put it, is a predictable state container for JavaScript applications. And is still one of the most popular libraries used for state management with React application. And for good reasons. Redux is very simple and powerful at the same time. And it's also very flexible, which helps us, we can shape it in exactly the way we want to serve our application needs. But this flexibility also kind of makes it difficult the first time you try to set it up. When I first started using Redux, I went through the documentation, I spent a few days there, then I read various articles about how to set it up, and this is what most people were suggesting at the time. So if I wanted to do an API call, I would have to first declare some constants, and this would take the shape of request, success, and fail. Then I would have to create an action creator to dispatch that request action. Then use an API service to call my endpoint. And usually I will have to add another third-party library like Redux Thang or Saga or observables. Then, depending on my response, I would fire a success action or a fail action. I would have to handle the data, the payload in my reducer. And finally, for every component, I would have to declare map dispatch to probes and map state to probes in order to connect my React component with the code that I had just written. And I had to do this for every single API call that I wanted to add in the system. And it was just way too much boilerplate. It was too difficult to add just a single more API call. And we gotta do better than that. There must be a better solution, right? Of course. And this is what I want to talk about today. And in order to find the solution, we need to go back to the fundamentals, and we need to write code that is maintainable, scalable, and readable. And in this instance, what that means is I want to set up Redux once, and then it should just work for every API call I want to make. I shouldn't need to add more boilerplate every time I want to do a new API call. So having said that, let's go and see how we can do that. So as I said, the first thing that I would do if I wanted to do a new API call, let's say I wanted to read a user, I would have to declare 3 constants for my action types: request read user, success read user, and fail read user. And the first improvement I want to do is get rid of this, because we don't really need them. We can compute the action type dynamically, and with a few tests, we can make sure that it works everywhere. Now, the next thing I would do is to create an action creator. And this is typically how it would look for the case I wanted to read the user. I would dispatch the request read user, do my get request, and then depending on the response, I would dispatch a success or fail action. And there are 2 problems with this code. The first one is that it's doing more than the one thing that it's supposed to do. It should only be responsible to send the request action, but it's doing the API call as well, and we're kind of mixing concerns here. And the second problem I see is that this code is very specific for the user entity. But if you think about it, if we want to read a thread or a group, the code will look pretty much identical. So let's see how we can improve this code. I'm going to have a generic action creator now, which I'm going to call read entity. And it's going to take 2 arguments, the entity name and the ID. Entity name would be the type of the entity I want to read, a user, a group, and the ID of that entity that I want to read. And it will return 3 things. The type, which is going to take the shape of request, read, and then the entity name, and I'm just making it uppercase for uniformity. It's going to return URL params, and this I'm going to use to compute the endpoint that I'm going to call. And finally, some metadata, and here I'm going to have a unique identifier that I'm going to use in my reducers to keep track of the API call. Next thing I want to do is move all the API-related business logic into a middleware. And here, all I'm doing is I'm listening on all my actions and see if any of them start with request read. If that's the case, I'm doing my get request. And I'm dispatching success or fail depending on the response. Two things to notice here is how I'm using the URL params I had before in my action to compute my URL. And that, again, I'm dynamically computing my types, so I don't need to declare those constants. Next, I want to talk about how we're going to structure our store. And this is how it's going to look like. I'm going to have a top-level entities key. And under there, I'll have a key for every entity in the system. And under that, I'll have two more keys, the buy ID and the read IDs. Under buy ID, I'll keep all the data that are coming back from the API. And under read IDs, I'm going to keep track of all the status of all my API calls. And if you take a look at the buy ID key, how I'm storing the data under that, it's in a very unique shape. I have this ID 1, which happens, it's this key 1, which happens to be the same as the ID, and then I'm storing the data. And this is how normalized data look like. And I want to take a minute and talk about why it's useful to store data in a normalized way. So this would be my typical response for a post that I get back from my API. We'll have a title, and then it will have nested data. It will have an author and comments which themselves have author. And if I normalize the data, it will look something like this. So in my post, I no longer have nested data in the author. I just have an ID that links to that data. Same with comments. And the advantage of having normalized data is that it becomes super easy to update them. Imagine I wanted to change the author's name from Jeff to Peter. With the unnormalized data, I have to do it in 2 different places. With the normalized data, only in one. And if you think about a large JavaScript application, if I go with the unnormalized version, I might have 20 different places where I have to update that. And it just becomes unmaintainable. With the normalized data, I only have to update it once, always. Let's move on to see how reducers will look like. So I'm going to have a reducer creator here rather than just reducers. So similar to my action creator, it's going to take an entity name, and it's going to return me 2 sub-reducers, the buy ID and the read IDs that we saw before. And every entity in the system will get these 2 sub-reducers. The buy ID will look something like this. I'm going to listen on any action types that start with success because they carry my payload. I'm going to check if my payload I have entities of this type, and then I'm going to merge them into state. And remember that every entity in the system gets this buy ID. So if for example, this is a buy ID reducer for the user entity, and I have users in my payload, then I'm going to go ahead and merge them. And the read IDs will kind of work the same way. I'm going to check if my type includes the read key. If yes, and this is the relevant reducer for the relevant entity, I'm going to go ahead and update the status with the like normal is fetching an error. And the last thing I want to do is, so when we connect React with Redux, we always have these map state to probes and map dispatch to probes. We always repeat them in our components. So I want to reduce even further the boilerplate, and I want to put them in a higher order component, which I'm going to show in a minute how we're going to use. And basically, this higher order component is going to pass to my children component 3 things: the read entity action creator that we saw in the beginning, an entity, which is, I'm using a selector here, and we're going to select from the buy ID reducer, and the status of the call, which I'm going to get from the read IDs reducer. So we've covered quite a lot. Let's recap a bit. So first of all, we got rid of the constants. We no longer need them. Second, we created an action creator to read any entity in the system so it can handle any entity. Then we move the API business logic into a middleware. Then we create this reducer creator that returns two sub-reducers, the buy ID and the read IDs. And finally, we move map state to probes and map dispatch to probes in a higher order component. And we've done that for reading any entity in the system. But if I really want my code to handle most of my API calls, I need to do that for create, update, and delete. And also for attaching and detaching entities, one entity from another in a many-to-many relationship. And if I do that for a single entity, multiple entities, maybe I want to read a single user or multiple users, then I should cover most of my API calls. And it is not much more code than what I showed to achieve this. And now I want to show you how we can use this in action. So I'm going to have a demo here. I just want to simply read a user in the beginning that has some posts, so very simple. And I want you to notice that all the code we've written had no mention of any entity. Although we followed the read user example, our generic code only had this mention of entity name. So we somehow have to tell our system what kind of entities we're using. So here, I'm going to call the getReducers function that we defined before for my two entities, the user and the post. And then I want to use this normalizer library for normalization reason. And again, I'm defining my two entities. Here I'm saying that a user has many posts, and I'm just exporting that. And just with these few lines of code now, both post and user can do any API call. It can do a read, create, update, delete, and so on, just like that. And I want to show you how we can use this higher order component that we defined before. So this is where you would normally write the map state to probes and map dispatch to probes. But this higher order component is going to pass it to my children. So here I want to wrap my component into this higher order component. This higher order component is going to give me the read, entity, and status. The read is the read entity action creator we saw in the beginning. Entity and status. Entity is the entity we're reading, a status is the status of the operation. And I have to tell my higher order component what type of entity I'm reading and the ID. And this is enough to read a single user, just this code here. So if I refresh, it works just like that. And I can kind of follow the same pattern for all the other API call types I want to do. If I want to update a user, for example, I have a similar higher order component. And this time it's going to give me the update action and the status of the operation. And again, I can just go and change the name here. And finally, if I, let's say, want to add a tag entity into the system, I want to tag my post, all I have to do is come here, add the tag, and here, need to export those. And again, just with a few lines of code, we can do all these API calls for the tag entity. And if I go here, I'm using another type of higher order component, this time to read multiple entities. And you can see here, I'm reading the tag. And just to go back and show you this first higher order component we use, there's no magic going on here. It's just doing the map state to probes and map dispatch to probes for us. It's connecting us with Redux, with this read entity action creator that we defined in the beginning. This entity is coming straight from the buy IDs reducer. The status is coming straight from the read IDs reducer. All right, that's it. So in summary, this code, we can set up Redux once, and then we can pretty much reuse it for any entity in the system. So it's great if we want to like reduce the boilerplate and then set it up and never have to worry about it again. Or even if we want to add any extra functionality, if we want to do optimistic updates, we do it in one place. It works for every entity in the system. If you want to find out more and see the full code, you can go on this repository. All the code is there for you to use. You can use it as it is, or you can just use it as an inspiration for you to set up Redux. Thank you very much.
Any questions for Ono?
Yeah, that was a cool talk. I think it kind of what you're kind of explained just reduces all the boilerplate that most people hate about Redux. So it was really cool. My question is just related to Redux in general. With the new, I guess it's not so new anymore, but with Context API, for me personally, the reason why I used Redux before was just to kind of put my data somewhere that I could kind of pass around different components. And since Context API, do you think there's kind of a use for Redux anymore?
Yeah. I mean, Context API, I would normally use it more for like UI to pass some state from like my parent component to my to like a very, very deep child. But I think Redux does a great job to abstract the whole state management thing. I've never done it with the Context API, to be honest, but I would imagine you would have to come up with something as good as Redux to implement your solution.
Cool, thanks.
Okay.
Cool.
Round of applause for Oni. Okay, so a few things before we wrap up. First of all, I think all of our talkers deserve a massive round of applause because they've done great. And I hope you didn't think you were going to have only one plug tonight, because I've now got 3 for you. So if you'd like to talk at this event, please, we want to get in touch with you. We want a variety of different levels of talk. So if you have a really talk specific on beginners or all the way to advanced, if you have whatever, please get in contact at hello@react.london. We also have a bunch of other meetups, including one called We Love Tech, which is probably our next most popular. If you are interested in finding out when or where our events are, including this one, please feel free to add yourself to our mailing list at red-badger.com. And finally, we are also hiring, believe it or not. So if you do want to find out a little bit more about what we do, please, or find out specifically about the roles that we're hiring for, please talk to me or any other badgers that are here at the pub later on, or you can go to red-badger.com/jobs. Just a reminder that we have got some space booked at the Marquee of Granby right now, which is the pub just outside. And yeah, thank you very much. Hope to see you at the next meetup. Thank you.